The last of the 8 properties, I'll do that property in two parts. First, we'll assume that f is an even function. So when we know f is even, this property holds. F of negative x is the same as f of x. So it doesn't matter whether you put in x or negative x, the output is the same. And the property of the definite integral says that the definite integral from negative a to a of f of x dx is equals to 2 times the definite integral from 0 to a of f of x dx. And one way to prove this is, what we can do is we can split this left hand side. So what I'll start with the left hand side, negative a to a of f of x dx. We can first split it into two integrals, realizing the fact that 0 will lie somewhere in between negative a and a. So if I split it at 0, it becomes from negative a to 0 and from 0 to a. Of course, integral of the same function. And one very good thing about this is that we have part of the answer. We have this is something which we want. If you look at the right hand side, this is something which we want. So we expect that this should give you the other part. Since the right hand side of our property is 2 times this integral, we have 1 times this integral. And if we can somehow get this is equal to that same thing, then we can, if you add them, it will get you to 2 times that integral. So what I claim is, I claim that this integral is the same as this integral. And let's actually show that. So I want to show that negative a to 0 of f of x dx is the same as my other integral. And since we are dealing with even functions, a very good substitution to make is u is equals to minus x, which gives you du is equals to minus dx, of course. And interesting thing happens when you look at the limits. If x is the lower limit, minus a, then u becomes negative of minus a, which is the same as positive a. And when x is the upper limit 0, u is equals to negative 0, which is the same as just 0. So if I were to rewrite this integral, it would become the integral of the lower limit becomes a, the upper limit becomes 0, and instead of an x we have a negative u, right? Because u is negative x, then this gives you x is equals to negative u. So this gives you negative u. And of course we have been doing this over and over again. Dx is the same as negative du, so I can put this du and this negative out front. But something interesting going on here, what you realize is that f is an even function. So it doesn't matter whether you put in negative u or positive u, it's the same thing. So this is the same as negative of the integral from a to 0 of f of u du. Because f is an even function, we are using the fact that f is even. And again, using the property that if you have a negative out front, you can swap the upper and lower limits, getting rid of the negative. So when you get rid of the negative and swap the limits, it becomes from 0 to a of f of u du. And again, what is in the name of the variable, right? So I can write it as f of x dx, which is what we wanted to prove. We wanted to show that this integral is the same as this integral, and when you add those two integrals, it becomes 2 times that integral, which is my original property.